Hey guys, welcome to the next video. So this is just going to be a summary of the ways we've turned alcohols into good leaving groups for our substitution and elimination reactions. So at the top, right, it shows the different types of acids we can use. So remember how we talked about using those halogen acids like HCl, HBr, HI? We'll go through the substitution pathway. If we're primary, we'll go SN2. Secondary or tertiary goes SN1. If we use an acid like H2SO4 or H3PO4, we'll go through the elimination reactions. For primary, we'll go E2. For secondary or tertiary, we'll go E1. Okay. Now, this bottom half, so let me just actually cut this off over here. Right. If we have an alcohol, we can turn it into a good leaving group using MsCl, TsCl, or TFCl. Right. And actually, you'd want to put that over pyridine. Okay. And so we put that over pyridine, and we get these ROMS, OTS, and OTF. And again, watch the previous video if you're curious to see what the structures look like. It's a very good idea to put them on your index card. Okay? And so we turn them into good leaving groups, and right afterwards, we would now react it with a nucleophile or a base to then do our SN2, SN1, E1, or E2. Okay? So all we just did using that MsCl, TS, or TFCl is just create a good leaving group. That didn't actually result in a, we didn't actually do an SN2 on it or E2, okay? So then we would have to react it afterwards with something to do an SN2, SN1, E1, and E2. And it follows all the old rules. So you can think of, like, let's say OMS as essentially a good leaving group like chlorine. So we would need to add a good nucleophile or something, or a good base, Then this next half, or next third, I guess, at this point, is again turning alcohols into good leaving groups. Now the catch is we can only use a primary or secondary alcohol with these three. Okay? Not only that, but once you add either SOCl2, the PBr3, PH3 PBr2, it results in an inversion of stereochemistry. So if I wrote out this example and I put SOCl2 pyridine, we get this. Okay? So remember, because in the mechanism, it will actually be an SN2. The chlorine kicks out that alcohol with all that sulfurs and the chlorine attached to it as an SN2 reaction. And SN2 will not work on the tertiary, which is why we are not allowed to use this stuff on tertiary alcohols. Okay? This right over here, using the tosylates, mesylates, and triflates, results in a retention of stereochemistry. Okay? And once just like we did with the tosylates and mesylates, once you add your chlorine bromine, right, you then afterwards have to react with a nucleophile or a base to keep going with our SN2, SN1, E2, or E2 reactions. Okay. Now, one thing I also do want to mention, now that you've learned these bottom reagents, essentially, it changes how you have to do synthesis questions. Okay. In the past, remember how we would use HBr, right? We would go backwards and we would use HBr to turn alcohol, and we essentially react with an alcohol, right? And we can put an alkyl bromide down. Now we have to use, you have to use PBr3 if you're using a primary or secondary alcohol. So let me just give you an example really quickly. All right, so we have this structure, right? Okay. And now we want to go backwards to put an alcohol in it because we want to do a cut, right? You want to essentially cut your molecule down. In the past, you've just been doing HBr and writing this, right? We can't do that anymore if we're on a primary, secondary leaving group. The reason is because in the mechanism, remember, we add another OH, protonates this, and we're going to get this to get kicked out. So now we're going to get this secondary carbocation, and because there's a tertiary right next to it, it's going to end up shifting, and we're going to get a carbocation here now. Okay, so the primary reason now we can't use HBr is to avoid this sort of shift. In the past test, it was acceptable because you didn't know this reagent. Now it's not, and you must be careful. So if we actually had this example again, in order to go backwards now, you now have to do PBr3 over pyridine. And now you can get your OH going backwards, of course. If you had a tertiary leaving group, because that PBr3 doesn't work, and because that tertiary isn't going to shift anyway because it's not going to form a more stable carbocation, you can now do HBr and get. Okay? So please just watch out for that. That is now how you must do these synthesis questions. You aren't allowed to essentially use HBr on a primary or secondary unless you, for some reason, are intending it to shift. If you're intending it to shift, then by all means do it, but just make sure that it actually works, okay? Remember, synthesis questions, it must be 100% product formation, okay? So it must always work. So validate what you're doing by going forward and seeing if it all works out. So I hope this little summary helped you guys out. The key thing to keep in mind is, remember, when we use the acids, it's a little bit of a different sort of rule set for the elimination substitution stuff. Using these MSCl, TSCl, or TFCl, we retain the stereochem. And afterwards, we've created good leaving groups, so then you use your nucleophile or base to do the reaction. When using the bottom three reagents, it only works on primary and secondary, and it always causes an inversion of stereochemistry. Then we do the nucleophile or base to do the E2 and E1, SN1, SN2 stuff. All right? So I hope everything here made sense. If something didn't, please feel free to email me or talk to a TA. If you're watching this on YouTube, also please feel free to leave a comment, and I'd be happy to answer your question. So I will see you guys in the next video.